Now let's see the machine in action. Okay, let's see. The ball went down the inclined plane, made the dominoes fall, popped the balloon, raised the flag like the flag is raised, made the ball drop, made the CD effect, made a hole in one, dropped that ball, turned on the switch which turned on this fan. The fan turned out the candle. Turned out the candle. It did the domino effect. The weight pulled the wheel and axle. The type 2 lever was squeezed, and therefore the toothpaste was squeezed into the toothbrush. Okay. Now for the physics analysis. I'm going to measure six steps: the kinetic energy, the potential energy, the velocity, the acceleration, the force, and the momentum. Those 6 benchmarks or steps, I'm going to measure them from using a ball, this ball. Using this ball, I'm going to put it from the beginning of the ramp until it reaches the end of the ramp right here. Okay? So, with that ramp and with that ball, I got a kinetic energy of 225 joules. Kinetic energy of 225 joules, a potential energy of 109.27 joules, a velocity of 0.3 meters per second, an acceleration of 0.3 meters per second squared, a force of 25 newtons, a momentum of 1.5 kilograms times meters per second. Now, okay, how did I get all those numbers? I did the formulas, the respective formulas for those, and I had to use these measures to get part of the formula. The canica, the ball has a mass of 5 kilograms. The inclined plane has a distance of 0.3 meters. The time it took the marble to go from the beginning to the end of the ramp was 1 second. The height was 2.23 meters from the ground. Okay, those are the 6 benchmarks. Now, the law of conservation of energy. Right. The law of conservation of energy. The law of conservation of energy is when a machine uses all its energy for its task, and when no energy is wasted, when there is no zero entropy. I'm going to use, the example I'm going to use for the law of conservation of energy is for the fan. The purpose of the fan is to blow hot air, right? If you turn it on, the purpose of the fan is to blow hot air. It's yes, to blow hot air. An entropy that it is using, like a way that energy is wasted, is when some of its energy, its initial energy, is wasted in sound. So that's a way that law of conservation of energy was not kept. The 6 simple machines are a lever, a pulley, a screw, an inclined plane, a wedge, and a wheel and axle. I used all of these except one in my machine. A lever, I used this lever, this type 1 lever, and this type 2 lever. I did not use a pulley, but a pulley is used to lift heavy, well not heavy, but to lift objects. Wait. A pulley can be like this. That's a pulley when you pull, where's my hand? When you pull on a string, like that's a pulley. A screw, I used 3 screws in my machine. That's 1, that's 2, and that's 3. A screw, in order to count as a screw, it has to have at least 360 degree, it has to go one way around. I used 3 inclined planes. This is an example of an inclined plane where a straight surface is inclined. That's an inclined plane. A wedge, I used a wedge right here. That's a wedge because it has a pointed end, which you can't really see, but it's there, the pointed end. Well, it ends in a pointed end, which makes it a screw. A wedge, I'm sorry. And the last simple machine is the wheel and axle, which I use 2 of those. This is an example of a wheel and axle where it has 2 wheels and a stick or an axle connecting both of those wheels. So that's my 6 simple machines. And for Newton's 3 laws, for Newton's first law, I am going to use the aguja, the wedge. The wedge was initially in the cardboard. So let me put it in the cardboard. Okay, so the wedge was initially like this, on top of a balloon. So it was at rest because the wedge was staying still, with a balloon, it was not moving. That was the outside force that caused it to move was this wheel and axle when it was on top of the table and it fell on top of the cardboard, which then pushed the wedge into the balloon. So the wedge was at rest and the wheel and axle pushed it down. So the wheel and axle are the outside force, upsetting the rest of the wedge. Newton's second law is force equals mass times acceleration, and I did that formula and I got force equals 25 newtons, so that's Newton's second law is 25 newtons. And Newton's third law, Newton's third law is when there is a action, there is an opposite and equal reaction. So I'm going to use another example of the cardboard. When the cardboard was still, it was lying on top of the balloon, so it was not moving. When the balloon was popped, this the cardboard went down and up a little bit, like it bounced a little bit. I'm not sure if in the video you can see it, but the balloon like the wedge popped, so the cardboard went down and it went up a little bit, like to like this sort of motion. And well, that's Newton's third law. This concludes my my physics analysis. So I successfully put toothpaste on a toothbrush, and here is my physics analysis. Thank you.